of all his stuff. So basically, the problem that happens to all of us also happened to the king. I request all the women in the group to pardon me. This is nothing against women. I'm not against women. My mother, my wife, my daughter. So I am for women. But the story goes like this. So the queen tells the king, hey, you know what? I don't understand why you rely so much on your minister. I think my brother, who's much better and smarter than your minister, must be made the minister. He must be running the affairs for you. I don't know why you are not allowing my brother to be the minister. I don't know. You don't like him. You don't like your brother-in-law. So the king, being like the regular husbands, he said, oh, no, honey, come on. Why would I not like your brother? He's good. You want me to appoint him as a minister? Dundee. But just for my sake, let me just give him a test. If he's gone through the test, if he gets through the test, he's the minister. Okay? I promise you that I will not inform my minister that he's going to be tested tomorrow. If you want, you are more than welcome to tell your brother that he's going to be tested tomorrow and be ready. The queen is all happy and she just runs to her brother and says, hey, buddy, be ready, man. Tomorrow is the test. It's a big day for you. If you make it, you'll be the minister. You'll be the chief minister of this kingdom, right next to the king. That'll be awesome. I love you, my little brother. Please prepare as much as you can. The guy goes around, downloads all the AI books, Python books, tries to work in Spider, everything. He tries his best to have all the knowledge he can. The minister is doing his job. Then the king comes to his attic with the queen, and he just calls his brother-in-law and says, brother-in-law, come here. Are you ready? Yes, sir, I'm ready. Tell me, what should I do, king? He says you hear a faint noise of somebody selling something. People sell something, right? Tomatoes, mangoes, like that. So king is hearing a faint sound of something being sold. He says, Sarji, please find out what is being sold. I don't know, I can't hear it. So the brother-in-law jumps, queen's brother jumps on the best Arabian horse. Giddy up! He goes there, reaches the place, finds out what it is, comes rushing back in 2 seconds, 10 seconds, says, Maharaj, they are selling mangoes. They're selling mangoes. Wow, nice. What type of mangoes are they selling? Immediately he goes, tarak, what type of mango it is? He comes back and says, it's Imam Pasand. Where it is coming from? For every question, he goes back and forth. The king asked 10 questions. He went back and forth 10 times. Okay, he's so tired now. So queen is so happy. Wow, my brother gave answers for all the questions. What a smart brother I have. She says, okay, brother. The king says, okay, go take some rest. You worked hard. So the brother goes in, starts drinking his badam milk. Then he calls his minister. Yes, Minister Ji, I hear a faint sound of somebody selling something. What is? Can you just check it out? The minister goes, comes back after 3 minutes, and then says, Sir, yes, what is being sold? Mango. Where is it coming from? It's coming from Imam Pasand. They say somewhere in, I think Imam Pasand is very famous somewhere in Pune, Surat, Pune area, I think, near Mumbai. He gives all the details and he says, you know what, it smells very good, it's very tasty, blah blah blah. And he says, like, when you're ready, I even told him, you know, you have to give us a good discount, and he's ready to buy. Now the king doesn't say anything. He just looks at his wife, the queen, and walks inside. The queen goes back to her brother and smacks him. Says, "You're a dumb fellow. Can't you just do it in one shot?" So knowledge is power. So he had the knowledge, all the knowledge at the right time, and he was able to deliver. So that's what you're going to learn today, and how the AI machines gain as much as knowledge to make the decisions. So you can apply this onto your life as well. The more knowledge you collect, the better you are. As some of the professors from Tamil Nadu said, yeah, it was in that movie as well, but this story I've been telling even before Singham came out. But it is a good connection. Yes. So hope you guys enjoyed the story. And without further ado, I let Doctor take over the session and enjoy the class. And remember, knowledge is power. Thank you. Doctor, it's all yours.
Yeah, sure, Ranga. Good morning once again. Hope you had a wonderful 2-hour session in the morning from Mr. Ranganath. So, right, so you might have got some, primer, like we call it as the, preview show, right? So he has only given the preview, like a movie trailer, like when Rajinikanth movie 2.0 comes, or Ajit Vijay or any Shah Rukh Khan movie comes, you just see the trailer. So he has only given the trailer of 2 hours. So he has an extensive session planned for tomorrow. We get into more onto the neural network, and then convolution and deep recurrent neural networks and all, right? So the morning focus for us is to give you details about the knowledge, right? So what type of knowledge you inferred from the story what Mr. Ranga told? Can you just quickly tell me? Like we are all human beings, right? We acquire knowledge. What type of knowledge you have inferred about the person A, person B, person C? He has talked about a few people. Can you just say like how they acquire the knowledge, or what type of knowledge the persons have gained?
They are thinking.
Okay, good. That is good. Like,
no response yet. Oh, you're not saying.
Okay. All right. So just start thinking now. The PowerPoint. Yeah. So I'll be talking about the knowledge types and agents. That's the focus today. I also have one program that will explain you how this giving knowledge, how we are giving knowledge to the machines, right? So basically in artificial intelligence, so far we have been keep on telling that we are making the machine intelligent. We are keeping the, doing whatever it takes to make the machine or agent intelligent, making a computer intelligent, making a computer control robot intelligent, and make the software think intelligently. We can make even hardware or software or any component. We are trying to make think intelligently, and how human thinks. That's basically what we are trying to do in the artificial intelligence, right? So what we are trying to do is how a human being thinks, right? How we think, how we listen, how you react to a situation, right? How we learn. More importantly, how you learn, right? Because human beings learn. Did anybody teach you, like say when you are going to a restaurant, how do you eat? So suppose you are a 5-year-old kid, you are going to a restaurant, right? Did your parents teach you like, oh, you go to the hotel, sit there in the chair like that, and then you try to wash your hand, go to the wash machine? Because they just follow. There are some set of things what they do at home. They just do that copy paste, right? So they learn and then decide, right? And then work. That's what human does, right? To solve a problem, any given problem, or to work with the situation, right? So that's exactly what we are trying to do. making the software intelligent, making the system intelligent by using the AI, right? So how do we, I want to ask you a question. How do we get the knowledge? Okay, let's start with Sonali Shelke. How did you get the knowledge of, suppose, do you know how to ride car or bike, Sonali, or scooter?
Yes, sir.
Good. So by observing, good. What is the other way you learn? By practice, excellent. Then by listening, good. Then by experience, then cool, right? So many people use a different way to perceive the knowledge, acquire the knowledge. That's why if you see that the mantra of our FDP, we say acquire, adapt, and agile. That's the purpose why we have put these three mantras, right? That will be very much, you know, aligned with this workshop. Okay, by demonstration, good. Okay, most of this are very good. I will follow up with you folks. Okay, so we trying to you know, acquire the knowledge, right, based on understanding, reasoning, and then interpreting the knowledge. Suppose I'm saying Mr. Ranganath is a doctor who deals with you know, who deals with a corona patient. What is your interpretation of this knowledge? I'm giving a knowledge that Mr. Ranganath is a doctor who deals with corona patient. What is your interpretation? Give some interpretation. Yeah, maybe as a scientist, he is dealing with the corona patient's data, right? Or, you know, no, he's not a doctor. He's not a doctor who put injection and gives a treatment. He treats the data. He's a data scientist. He's a data doctor, not a corona doctor. Okay. Anyway, so human know things, which is the knowledge, and you know what knowledge is, you know, useful to perform different actions, right? How machines do all these things comes under knowledge representation and reasoning. So basically, we are going to tell machine, hey, this is this. Like say, a mother always tells, you know, to the kid, hey, you know, this is a moon, this is sun, he is father, this is brother, sister. Like this, we introduce, right? And also some they acquire, right? Say they go and touch the heat, and then, you know, they take the hand out, or, you know, when they're trying to make some mistake, they learn, right? So, but now when it comes to a machine, so machine needs to know the knowledge. So you have to, in some way, you have to make the machine to understand the knowledge. You have to represent knowledge such a way so that machine can understand. So that is what called knowledge representation and reasoning. So this is one of the important part of the artificial intelligence, which is concerned with AI agents and all the, you know, the program which deals with the expert system. So this knowledge representation is responsible for representing information about the real world. What is that inference you are getting by looking at this mobile phone? I am holding the mobile phone and there is something is there in my hand. What is the knowledge you infer about this? You're a human being. What is the knowledge you are interpreting? Or what is the knowledge you are perceiving from this? Okay, good. Color, size, shape. Phone is black. Very good. Keep going. You know, there is one object which is holding the another object. There is a wire connected to. Did I tell that? Right? So there is a wire connected, and then it is getting charged. Very good. Deepika Sharma, excellent. Getting charged. Then, if this person is holding this phone like this for a longer time, his hand is going to pain, right? So you have to do something about it, right? So this is basically what we are talking about. A man showing a rectangle object. Very nice, Venkatesh. It's a different perspective. So this is how, see, look at it. 5, 6 of you are interpreting the knowledge in a different way, right? So that means you should give some kind of a nice representation. Suppose now instead of Prashant Kulkarni, Deepika, Vikas Dubey, Prashant and other people, now I've deployed an agent. So agent has to understand this, software agent, hardware agent, something to understand this and then give, you know, interpretation, right? That's where we are heading now, right? Good. So, what we represent, what to represent? So, we represent an object and we represent some events. Holding is an event, okay, and talking is an event, right? Event that occur, in the real world. And what type of performance, right? In terms of, describing, oh, he's going fast, he's going slow, things like that, right? And meta knowledge, knowledge about the knowledge, right? For example, what knowledge I have, probably I have 50% knowledge of big data. I have 20% knowledge of this. So in database management system, we call it as a metadata, data about data. Suppose I have a table called the customer, and that customer table contain all the information about customer. But there will be a metadata for the customer table that says this is a customer table. This customer table has this many rows, and this customer table is stored here, etc. So information about the customer table, that is called meta knowledge. Then facts. What are the real facts and the truths about the real world and what we represent? Can you tell me a fact? Can you tell about the fact, today's fact? What is a fact today? Today's fact. What are the facts you have, what you can tell about today, about a fact? It is hot outside, very good. Deepika, it's actually in our area, it's raining outside. It's a kind of a warm weather. Okay, that's why I'm wearing, my air condition is not following Mr. Ranga's instruction. He came and then helped in designing the fuzzy logic code, but it is increasing its, the temperature is going low, then so I have to put my blazer. Okay, we are dying. Oh, corona cases are increasing, we are dying. Yeah, right. Good. Don't say we are dying. The percentage of patients which treated or whatever. Okay, that's fine. Let's get back. So that is about the fact, right? And then knowledge base. Finally, we store all these things in a knowledge base, right? So basically, we represent everything as a sentences, knowledge bases or knowledge sentences. For example, what is that sentence you can make about me now and make about Mr. Ranganath? Ranganath, I think you saw Mr. Ranganath talking to you in the morning, and I am talking to you. What type of knowledge you represent about myself and Mr. Ranganath? Just by today only. You have seen him. Mr. Ranganath, you can show your face once. Ranganath? Ranganath, are you there?
Yeah, I'm showing my face.
Oh, really? I didn't see your face. Okay, let's see. Ah, yeah. Yeah, I see. Okay, now you see this. There are two guys are there. What type of sentences you can make out of me and Mr. Ranganath? Don't talk about our knowledge. We are not talking about our knowledge, our subject area. But just looking at us. You speak very well. Spectacles. Ah, good. I am a clean-shaved guy, and our man is, having a mustache and, trimmed,
spectacles, a speaker,
Oh, okay. Excellent.
punctuality, complexion.
Excellent. Cool.
Smiling faces.
There's a curtain on my background. There is also curtain on Ranganath's background. There is also some, Sami photos are there, right? So these are all some sentences you can make, right? So that's basically, these sentences will be created, and let me put back to the system. Yeah. So we represent the knowledge, right? There is a knowledge about a particular object, structural knowledge, right? So like say, phone is rectangular in shape, moon is, circular or elliptical in shape, and this is in this, right? And what is the relationship? Suppose I have this, keychain. Okay, so this keychain, there is a one line, there is one container. What's the relationship it is holding, right? So these are all giving the relationship about object A and object B, right? So So we have a relationship between object and the concept, that is structural knowledge. Then we also talk about declarative knowledge, object facts. Okay, madam says one fact, no, charming, or something complex, something she says, right? Some declarative knowledge, right? You say declare, this person is a professor, this person is a doctor. You just give the knowledge about, declarative knowledge. We are declaring it. Okay, this FDP is supported by SASTRA University, and this FDP is initiated by AICTE, ATAL scheme, things like that, right? And we also have a heuristics knowledge, rule of thumb, right? So what type of, we talk about bricks, right? Bricks says that robot density is very less in India. That is a heuristic knowledge, because last over the few years, the number of patents are less in India, right? And then meta knowledge, knowledge about all these things, what procedures we have, and all those things, information about everything. And then rules and procedure. This is a procedural knowledge. What are the rules Ms. Sudha madam has dictated to you and Ali Rani madam dictated to you in the day one, beginning of the session? In fact, Ranga also insisted, I also insisted. What type of procedural we have given to you? Can you put something on the chat? Okay. Okay, be punctual, be on time, mute.
Downloading Anaconda, 80% attendance.
Good, excellent, cool. So this is the theory. I'm just skipping it. So declarative knowledge.
Audio, assignment, 60%
Excellent.
marks in test. Viswanathan Ramamurthy, music director.
Wow. Okay, cool. And procedural knowledge includes strategies and agenda, right? And meta knowledge about the knowledge of the knowledge, and heuristic knowledge and structural knowledge. Okay, let's see this. What do you understand from this picture? See, this basically represents the real world. Suppose there is a fire, right? You are sensing the smoke, or the gas stove is on. You are sensing it. What do? You make some decision, right? What knowledge which, there is a gas smell. How you got that knowledge? Because you already have that knowledge, which the smell of a gas, smell of a smoke, smell of, the idli or sambar or dosa or vada or whatever. You all know all this rasam smell and everything, right? Oh, this is a gas smell, some gas leakage, right? So that knowledge has come there. Then there's a decision has to be made. Then you take an action, right? So there is one decision maker which act by sensing the environment and using the knowledge. All we are doing is, there is an environment, there is a knowledge, and there is a decision maker. So decision maker can be an agent, and that agent will get an intelligent using the knowledge. You can get intelligent until you get a knowledge, right? So the knowledge has to be represented, knowledge has to be fed, some rules have to be given. So decision maker, the AI system, an expert system, will take the decision and perform an action. So this is very, very important for you to understand, right? So this is basically a cycle of a knowledge, AI knowledge. So normally what we do is we perceive the, the environment, what is there, what's happening, we perceive, right? Based on all our senses, right? That's why Ranga talks about the neural network. So this is basically going to connect to the neural network. We're talking about perceptron, right? Neuron, right? And then, so basically we trying to learn and then look at the knowledge. Hey, how that after learning, I'm going to represent. For example, I've learned something about some of the participants. These participants are, very much attentive to the session. And then when we ask question, they start jumping in, right? And sometimes, there I can see that many people are giving the response, right? So that is kind of what I've learned. And then every time we have to, myself or Ranga should go and then check. And Sudha ma'am also go and check any questions are there or not, right? So things like that. So that is what, and we did some reasoning. And then based on that, we can plan and educate and evolve the system, right? That's basically a knowledge cycle. Perception, as I said, it can be visual perception, audio, or another form of sensory input. We have learned about 7 senses yesterday. What was the 7th sense? Do you remember? No, not Ranga's favorite word. Computer is a common sense. I'm not talking about that. We talked about 6 sense and one more 7 sense I said. Okay. Anyway, learning and then representation and reasoning and planning and execution, right? So now let's see, how do you represent relational knowledge? Mahendra Singh Dhoni. Mahendra Singh Dhoni is a player 1. What was the number, the shirt number he has, which is 7. So what do you understand from this, Ranga, you ask, I'm asking a question now. What do you understand from this relational knowledge? It's a table with some relation. Okay. What do you infer? What are all the different knowledge which you can represent by looking at this table? Can you put some few points?
Lucky number to him.
Okay. What is the knowledge about player 2? What do you infer?
Player 1 is 23 years old.
Oh, cool. Excellent.
Player 3 is overweight.
Oh, excellent. Very good.
He's young. Player 2 is the youngest.
Excellent. Very good. So that's basically what we are talking about, knowledge. So the knowledge now represented simply, and based on this is in a database table, relational system. So you can make a decision based on that. Like say one of the decision which was made, the knowledge, the best knowledge which we obtained was player 2 was the youngest person, right? And then, having the lowest weight, and player 3 is probably overweight, right? So those type of things. Then that's the inheritable knowledge, right? So there is a knowledge which basically, if you look at it right now, I am holding this phone, okay, and we are doing with a computer, right? These are all inherited what? From electronic, right? So it's a computer or mobile device. We simply call it as a mobile device or electronic device. So all these electronic devices inherit some of the characteristics that you study in the object-oriented programming, right? About inheritance properties. So there is a inheritable knowledge we get. For example, what do you infer about Mr. Ankit? Who is Ankit? Can you just tell about Ankit by looking at this diagram? Who is Ankit? Who is Peter?
Waiting. Ask one question. They are saying football player. Just ask one question, please.
Yeah. Is Ankit a cricket player?
Ankit is a football player. Peter is cricket. Ankit is
Oh.
not a football player. No, sir.
Okay.
We have 94 participants. We request all of you to please respond. There are only a few of the participants who are responding actively. So please respond. It enhances your learning experience. More and more you answer, you start thinking. Yeah, a lot of responses. Ankit is a football player. Ankit is an adult male football player, says Vishali.
Excellent. Very good. Cool.
Very well done. That is exactly.
I'll move on now. Yeah. Next one is inferential knowledge. Okay. So this one is inheritable. So we talked about simple relational knowledge, how a relational values, the rows and columns we represent and understand the knowledge, represent the knowledge, and also how we define the knowledge using the inheritance characteristics. Now we're talking about inferential knowledge. Inferential knowledge is Marcus is a man, all men are mortal. What does that mean? That means Marcus is a man, all men are mortal. That means, we say, how do you say immortal and mortal, right? So we say we can represent this as man is Marcus, right? Marcus is a man, right? For all X, man of X, they're all implies to mortal. So all will die. All men will die. That's because that's what it means. All men are mortal. So all X, if the X is going to be man, and then it implies mortal, right? So that's basically what you infer. So when say all men are mortal, when Marcus is a man, Ranga is a man, Venkat is a man, we are all mortal. Okay, so that is what we infer. Like say when there is a raining, what is that you infer? There is a heavy raining in the outside. Outside we see there is a heavy raining. What is the inferential knowledge you will get?
Cool, traffic jam.
Okay, roads are probably wet.
Can you give another example, sir, please?
Yeah, go ahead.
You're asking for another example.
You can give one, Ranga.
Paddle.
You can give one, Ranga. Ranga, you can give one example.
For this inferential knowledge.
Yeah.
Okay, I can give you this example. Birds flying. True. Okay. Then I'll give another example. Men drinks coffee. All men like coffee.
Yeah.
So what would you infer from that? Can you infer that? False, right? Venkat drinks coffee. Can I say all men drink coffee? Can I infer that? No. Okay.
Good. Excellent.
Venkat is wearing spectacles. All men wear spectacles.
I'll remove my spectacle. I can still see. I'm just kidding. Okay. All right. Cool. Thanks, Ranga.
Just one thing with relating to them.
Yeah.
All professors in a college have master degree. Does it mean that all professors will have MTech? Yes. Very good. That's it.
Cool. Excellent. Okay, cool. So let me go back to the slide. Procedural knowledge. So basically, it is like, if all of you come on time, then we should be able to have a effective session. If everybody if 50 participants join the session, then we are starting the session, right? So in the morning I was talking about Lisp language, right? My first presentation, first guest lecture was on the Lisp language. This was back in 1989 or 1990. So the third year. Lisp and Prolog was very famous on the representing the procedural knowledge. It is like you dictate, if this is this, then you do this. That is basically, we call it as a procedural knowledge or rule-based knowledge, right? So how do we represent the knowledge, right? So we use logically, we can represent using some semantic network, you can represent, you can also use the production rules, right? That is basically if then else rule, or you can represent using the frame. You can create some frame. Okay, so let's see some example. Okay, the logical representation, basically we give a syntax and then semantics. Okay, Mr. Ranga is going to talk about the different types of logics. Okay, that time he is going to tell more about propositional logic and predicate logic, right? So in the semantic network representation, what we do is we are just going to give some statements. Jerry is a cat. Jerry is a mammal. Jerry is owned by Priya. All mammals are animal, right? How do I represent this as a diagram, a semantic network diagram? So basically you can say we can represent the statements as nodes and we can use the arcs. Okay, let's see this. Now, the same thing if you see, we have put all the objects like a Jerry, cat, mammal, Priya, okay, and then color, right? We just put color as one object, right? Color. Now you see this. Jerry is colored white. Jerry is owned by Priya. Jerry is a cat. Cat is a mammal. Mammal is an animal, right? So this is the way you represent the knowledge, right? So one example, probably you can try in the homework assignment. You try to take your college, your department, and then trying to represent using the semantic. In fact, for your research work, you can use the semantic network to represent your concepts. So nowadays we are using, it's called ontology. We are using ontological representation of the data, right? So this is about semantic network. And then the easiest one is a frame representation. We can just simply create a card-like structure, right? If you go to a hotel, they will give you a frame, right? Have you seen that? A card they will give you, the menu card. What is it? You will get it from that frame. You can just, it's like a kind of an index card. You go, they will give you a price catalog, right? So all those things are in the form of a frame. Okay, see some example of a frame. So about a frame for a book. Okay, if I see that frame, I have like some titles, I mean some slots and then some filters. By looking at the title, okay, it's artificial intelligence. The category is computer science. Author is Peter Norvig. Edition, 3rd edition, year 1996 page. So every index has a value. Similarly, like say the another one, like say, see this. Peter is an engineer as a profession. Oh, by the way, today is an engineer day. Congratulations to all the engineers. Happy Engineers Day. Let me show my face.
Thank you. Somebody also mentioned that in the chat.
Yeah.
Asked what is it? I mentioned it.
Congratulations to all the engineering doctors and doctor engineers. Okay, cool. Excellent. Happy Engineers Day.
And also what the slide doctor is representing is also in key value pairs, like what we saw yesterday. These are key value pairs.
Exactly. JSON file. We call it as a JavaScript object rotation. JSON file will have a key and value. So the name is a key, value is this one, filter, right? The slot and filter. So age is 25, he lives in city London and the country is England. So this is how you represent the frame. You can use these notations, as I say, like a semantic as well as this frame representation. You can use it for your research. It's not necessary that you have to follow the same monotonical approach of representing the information in your thesis and synopsis. You can try to use some frame like representation of your data. You always do a data profiling, right? You can represent like using frame. Then this is production rule. I'm going to show an example of using the production rule. I have written a code I will show you, right? So basically this is like a if then else type of a condition. If a condition, then there is an action. So it has 3 parts: production rules and working memory, and then how to recognize act cycle. If you recognize and then you perform action, right? So that basically called recognize act cycle. We'll see an example. Okay, what do you infer here? That's a production rule. If a person, for example, at bus stop, if Ranganath is at bus stop and bus arrives, then action, get into bus. Ranga will go into the bus. If I am on the bus and paid, okay, I am on the bus, already there on the bus boarded, and already paid the ticket, and if there is an empty seat available, then action, you will be sitting, you will be seated. That is an action. If on bus and unpaid, then what do you do? Then action, pay charges. You'll be paying and then pay the ticket. If bus arrives at the destination, wherever I wanted to go, then action, get down from the bus. Please remember this carefully. This is what type of, the rules we give it to the robos, right? And, intelligent agents. So agents will follow this type of instruction and then, perform the action. Sometimes it does better than the human being. That's where the unsupervised and then reinforcement learning will come into picture, right? So that brought, with that I'll just show an example, then I'll quickly explain about AI agents and the environment. Okay, so are you seeing my screen now? I'm showing you one code.
Yes.
Yeah, so see this. This is the expert system code, because you see this now. This is not a human being. There's a machine walking. A robo is walking on the road, but we have written one AI expert code. That expert code is saying that be cautious because light is blinking yellow. What do you do when there is a blinking yellow? It is nothing but yield, right? You have to stop. Slowly you will go, right? If it is a red means you will completely stop. But if it's a blinking yellow, what you will do? You wait and yield, and then if there is no other cars or things are all going, then probably you will proceed, right?
What, so doctor? You are not in India, is it? Red also we go, doctor.
Actually, this brings down to one thing when my...
just kidding, carry on.
I know. Actually, when I was in US, even in the morning, I was taking my wife to a hospital in the early morning, 4:30. I was driving my car, and then there was a signal. I stopped, okay, and I stopped. Many other people also stopped. There is absolutely there is nothing on the road, right? So we stopped, right? So anyway, the blinking yellow, it's basically a yield sign, right? Just for, okay, fun, cool. So let me show the code. All of you get ready to do the coding. Now open your Anaconda Navigator, okay, and then you're going to do one simple program. Then I'll explain you about the agent. Okay, I'll put the video off. Okay, ready. What you need to do first, you open up your Anaconda Navigator. You already open your Anaconda Navigator, all of you?
You probably give them a couple of minutes.
Yeah.
Yes, a lot of them says yes. So
Excellent.
you can paste the code on the.
Absolutely good. So there are 2 or 3 ways to install the packages, right? The one way is you can click here, environments. Then you can see here what is installed, what is not installed. See, if you just say installed, right? So you can just see installed. That shows what are all the things we have installed, right? So we have installed so many, packages, and you can see the version also, right? So like say we see pandas, right? NumPy. You see that NumPy is here. Array processing for numbers of strings, records, and objects, right? 1.18.5 is a version. It's a free open source code. And pandas, high performance, easy to use data structure and analysis tool. So these are all we have seen. So to know about all the packages, you can just go here to the environment and see install. And if something is not installed, you can see it is not installed, right? And here also you can go and then search the package and update the package. Whichever is visible to Anaconda, they will take it. And there's a documentation also available. You can use the documentation, right? And it will take you to Anaconda Navigator and documentation, which is on the cloud. Okay. What is Navigator? All those things will be there. Okay. Now, this is the what we want to do is now you go here, click home. There are 2 ways you can install the package. Now I'm going to show you to install one package. You can click this command.exe prompt. It will open up a prompt. Okay, so you can open up the prompt where you can install the software, or you can go and then open up your notebook. What I did was I already installed one package. I'm going to show you. This is I opened from the command prompt. When I open this, all of you do it along with me. Click this. Did you get this black screen?
No, wait, no responses yet. Yeah, a few of them are saying yes.
Okay, cool, excellent. So what you want you to do is, now we are going to install one expert system package. I'll put this command in the chat window. We are going to do.
Sridevi, Asaitambi, you just need to click on that, madam. Click on that command. When you open Anaconda, please click on the first option, command prompt. Yeah, please do it again. They're saying, just do it again.
Yeah.
Bit slowly, please. Do it a bit slowly, please. They're saying.
Okay. Go to the Anaconda Navigator. There are so many icons will be there. The first icon is command.exe prompt. You just click the launch button. It will launch. Okay. So then I am going to put.
Stop there. Are you guys able to do this? Just get to the prompt first. Okay. Everybody has done it. Okay.
Yeah, Python, you can just run any Python command, etc. Right? So now what I'm going to put in a chat window, kindly take that from a chat window. There is one package we are going to install for our, where is the chat? I'm not seeing the chat.
Click on the 3 dots, yeah, chat, right there.
Okay, so I just put one command, pip install expert A. That is the package I'm doing. Take that, copy, paste. I'll increase.
Just type it. If you can't copy paste, just type it.
Yeah.
Install expert A.
Yeah, I will increase the font size.
Yeah. Menaka madam, what is the problem? Why are you not able? Your OER said no, sir. You're not able to open the command prompt. Downloading, yes, correct, Vishali madam. Yes, it will download. Yes.
Yeah.
Come fast, depending on your internet connectivity. It will download
Exactly. You will be seeing like this.
Done. Yeah, you will see, and it will start installing after it downloads. So give it some time. Once it is done installing, it will come back to the prompt. So if it has come back to the prompt, it means it's successfully installed. You should not see anything in red. Okay, so all of you, whoever has completed, yeah, please respond here. Yeah. Start
Okay.
back to prompt. Yeah. Pretty much everybody is saying done.
Excellent. Good. See, you would have seen this downloading. Now it is automatically going and downloading and collecting all the bundles and everything. So there is collected some packages and then successfully install the Experta 1.9.4 frozen dictionary schema. This is one nice expert system which you can try. I'm going to only show one program today. It is for you. You can go and then learn other packages. You can build your own expert system, AI expert system, right? Or I hope all of you have done that. Mr.
Yes,
Ranga,
all of them completed. All of them completed.
excellent. Now, if you have done that, open up the Jupyter notebook.
So as a part of daily routine, we request all of you to just, when you come in the morning, just open up Anaconda Navigator and then also keep one Jupyter session open.
Yeah.
So it will be easy.
Right. And then click the new. Now you are going to open up a Python interactive notebook. So you're just going to click the Python 3.
Sangamesh sir, that Experta is a library which has got packages for the expert systems. They have already, since it's an open source, they have already done a lot of, like we explained yesterday in NumPy, Panda, that is a package. So they have all the related expert system related functions are already pre-built. So you can just call them and get it done. You don't have to rewrite it.
Exactly.
So that is what Experta is. And this pip install.
Excuse me, sir. Sorry to interrupt, sir.
Yeah. Yes, sir.
Sir, is it Anaconda package, sir? Or specifically for any specific like command prompt or Jupyter
This
package?
installation of this package, if you have to do it for Python, you have to do pip install.
Exactly.
The
It is
same
not
package, if you want to call in R, it is install. It is a different command. So this is not related to Anaconda. Pip install is related to Python, sir.
Exactly.
Okay, sir. Thank you, sir.
And for Anaconda, there is something called Conda space install. See, anything related to Anaconda Navigator, components and things like that, then you use Conda. Pip, as Ranga says, pip is for installing any Python related packages. And one thing, you can write your own expert system. See, you have learned all these things. You can define your own expert system, A, B, C. You can define all your rules. You can do your own code, but it is going to take a lot of time. Rather, you can use an existing expert system, trying to configure and make it work. Like how we are making the mobile, configurable mobile. All is done. You is simply using it, right? So that's the way you can do it. Okay, let's go further. So what is that I want you to do is, I'm going to give this code first. First, we are going to import these two packages, right? So I'm just, I'm going to put this in the chat window also. Let's do step by step. So now I have sent you two message.
Some of them is getting a little late.
Some of them they are telling it is slow.
Installation, depending on
we will give another 2 minutes or 1 minute.
Whoever has completed can take this code and paste it. We'll wait 2 minutes.
They can.
Okay, I copied and then pasted it there. So you do it in your Jupyter notebook. Then you just run it. So this will confirm that Experta package, we are importing star means we are importing all the classes, all the functions, everything written in the Experta. So somebody was asking, what is Experta? Experta is a Python package for library system, right? So there is a lot of GitHub. So this is the Experta. You can use pip install Experta. That's what we have done. So they have given expert system. They've given a library for building expert system inspired by Clips. So this Clips is one of the bigger organization. They build out a lot of tools for the expert system. So you can just go to this clips, wherein they will give you a lot of documentation on how to build the expert system, right? So you can build your own package. You can import that package. You can write some package and you can put it as a package, and it can be imported by others. Have you done this?
1 second. Sangamesh sir is getting invalid syntax. Where is it getting, sir? Sangamesh ji, where is it? You are getting the invalid syntax?
Sir, excuse sir. No, sir. Now I got it, sir.
Ah.
It was been rectified, sir.
Okay, done.
Thank you, sir. Thank you. Thank you.
Okay. Now the first step what we are doing is we are going to use. Oops, sorry. Next one, I'm copying the code. Let's do step by step. So let me close all these windows so that I don't disturb. Yeah. So I'll copy this code there. Anybody can tell me what is that we are doing with this definition? This is a class. What is that it is doing? Any idea?
Traffic.
Go ahead, sir. Ayub Khan. Tell us, sir.
Yeah.
Traffic light. Nothing.
Yes.
Traffic light controller. Importing relevant packages. Messenger traffic light. Creating class. Traffic
Very
light controller.
Yeah. So we are simply creating a traffic light class. That's all. It is a traffic light. If you give the fact, okay, the fact is about the traffic light, whether it is traffic light is there or not, right? So it's about that knowledge about the traffic light. That is one class which we have created. And then now we are creating one class for robot cross street. There is a robot. That robot is going to be crossing the street using the knowledge engine, right? We talked about expert system. We talked about different types of knowledges, right? So we are going to use what knowledge we are going to use, the knowledge engine. So just run it.
Yeah, you didn't paste it. You didn't paste it here.
Oh, yes, that's my mistake. Yeah, now I copied it and pasted here.
Yeah, got it. Yes.
So this is about the production rule, right? We studied that the concepts of here, right? We talked about knowledge representation, and then we talked about the production rule, different rules. So this is what we have done. Okay, we are just giving the knowledge base and inference engine. We are giving all these production rules, and then so that the system can be configured, recognize, act, style. So that's what basically the last type of knowledge I'm showing here. Okay. So now what do you understand from this as a human being? What do you understand?
No responses. Have you all completed running the code? Yeah. When green light glows, you walk. We can cross the road. If green, then
Excellent.
walk. Green means walk. Traffic signal.
Excellent.
Okay.
Excellent.
Rule.
Good job. So this is basically the production rule. We have given the if then rule. Okay, we are checking the light. The fact light is on. What is the color of the light? Is now 1 second. Let me turn on my. So the light is on, the knowledge engine, giving all the inputs, and then now the green light self, that is the same instance we are trying to do, then it is okay. You can walk. This is one rule we have configured, right? Now I'm going to put you some more rules.
You saw a live demonstration of knowledge engine. When the pop-up came, doctor's knowledge says you have to plug it in. Otherwise, the computer will die. That is knowledge engine.
Exactly. Yes. And now the next one. Another rule we are giving. Unexpected indent. You have to do it correctly. Let's check that. I think you put it like this correctly. Now I'll copy the three things correctly, because Ranga also said that indent is very, very important. Otherwise, it doesn't know. Now I'll give you the code, best example. Okay. Can you
Yeah,
please copy all the three?
yeah,
Because that's the first one is class. Other
yeah.
thing.
Just use the complete one. And doctor, we lost your voice. Are you speaking? We don't hear you. Now it's
Is it okay now? Really?
We lost your voice. Yeah.
Okay, cool. So
So
now
it's working. So please see where look at the indentation on
the whole
doctor's on the screen. It has to be like that. Yeah, please show the full screen. Yes. Okay, working, says Professor Vikas. Done. Prashant Ji, Tanuja Madam says yes. Punmudi sir says yes. Yeah, a lot of dones have come.
excellent. So now we have
We are just
created a
defining the
class.
class. So if you look at the code, you will not get any results. We are just class, and we are within that we are defining functions.
The rules.
We have to execute them. We are just giving the rules. Correct, Professor. Go ahead, sir.
Yeah. So you have this class, robot cross street. That class, when it is fed with input as a knowledge engine. So now we are training the robot cross street with these rules, and we are saying that if the light property of the color is green, then you can give an indication that it is a green light. Self can walk, and if it is a red, we are changing it. It's a red light. Self, you don't walk. If it is going to be color, okay, if it is of a yellow color, or if it is a blinking yellow, then we are giving a different message, cautious message, right? Self to a light, be cautious, because light is what? The color can be a yellow or blinking yellow. This is what we have defined. We have defined a light class, right? And we have defined a class for the robot, right? What robot is going to follow the knowledge engine. This knowledge engine consists of this many production rules. Is that clear so far? Now we are going to execute and test this with a code. Now what we are going to do, there is going to be some engine, right? That may be a machine. Now we are going to instantiate that. Now we are going to run the code. Let me run it first, and then I'll show you. Then I'll give it to all of you. Now what we are doing, I am just instantiating. I'm creating one robot. I'm creating one engine. I'll copy this for you. Run that. Please do that. Put it in the engine equal to robot. In an object-oriented programming, we create an instantiation. This is a class. We just create an object. Now we are creating one object called engine. Like human being knows a red light, he will stop. Right? There is going to be a robot with an engine that basically crossing the street. Okay. Then now we are going to reset the machine with the property. Now we are training with the knowledge engine, right? So engine we reset. This engine is basically this robot cross street. We have only given a few rules, right? There are few more methods are there. We are not defining it all, right? If you go through the package, you will understand more about it, right? So now we reset the engine, right? And then now we are going to declare, this is a declarative knowledge, right? We are declaring that the color of choice is green, yellow, blinking yellow, red. So now we are giving the color can be of green, yellow, blinking yellow, and red. Okay, so I will copy these codes. Engine reset, I'll copy. Already copied. Okay. Now we are giving the color of. Yeah. I'll copy this. Now we are giving color of choice. Okay. So we can have the declaration knowledge. So we have a green, yellow, and then blinking yellow. We can declare. So it automatically pick up one color of blinking yellow. If it blinking yellow, now we are giving a color of choices blinking yellow. Now we are going to run the engine. Now the engine is going to run. What will happen now? What do you get? Because now engine is now I'm going to run. When there is going to be a blinking yellow, what should happen? be cautious because light is blinking yellow. Well, that is what we have given the rule. Are you getting it?
Yes.
Again, everybody is getting it. Engine run, when you run that engine, okay, you can change the properties. Okay, the color of choice, you can change it, and you can play with this code. I don't want to go more. I can give you one option here. Suppose I will just change the color of code. Okay, declare choice. Okay, so I'm just going to give. Okay, now I am going to do the engine dot run. What will happen? Don't walk. You want to try this? I'll give you. Now I am declaring. I'm dictating. I'm giving the inputs to the robo. That robo is seeing that. How
Light changed. They have done light equal to color, green, walk. They have changed.
Excellent.
Excellent.
Sridevi, good job. Excellent. So basically, the sensor, the robo is with a sensor, with a light camera, right? So like now in the camera, that's how the AI is going to work. So basically, there will be a camera with that sensor. I mean, in the robo, it will be taking the picture. Image processing will happen, and you see the light. The light is red. So that is a declarative knowledge. It receives a knowledge of red. Then it was, coded like, oh, it is a red. Don't watch. Try the other one color now. I think there is a green. No, somebody has already trained.
Yeah, they already tried. Sridevi Madam, Professor Vikas Dubey, they have tried.
Excellent. So I will just try one. Let's
Orange.
give a different color.
Oh, Sangamesh
That's
tried orange.
That's what we are going to do.
Sangamesh, what did you get?
What is that? Why it doesn't work? Won't work.
Yes, sir. It worked, sir. I tried it with some colors, so immediately it came to my mind orange color. So I just entered orange, sir.
Okay.
Yeah. Thank you, sir. It worked out, sir.
Okay, good.
Very good. Very good.
Blue. Okay, I gave blue and then run. Okay, but it may not have, because blue it won't give, right? Because it was not. Did you get any answer?
No result.
Yeah, because we did not code the knowledge. We did not tell what to do. That is the dumb machine. You know what? Remember that Rajinikanth movie, Kuthu na Kuthiro. Okay, it doesn't know how to react and think. That's what the 2.0, he says like it is just a dumb machine. That's what that villain will say.
Good example is TV pode. So he'll take the TV and put
TV,
it down.
exactly. Put the TV, then down, they'll just put the TV. So that type of thing. So we have to know result for orange. One color I will try. Finally, then we'll have a green.
What output are you getting, madam? Menaka madam is getting an output as light color equal orange. What output, madam, you are getting? Can you just tell us what is the output? Oh, this statement itself is output. That's why. Okay. No, that is not
green.
You should say something. Then that is not the
exactly. Yeah. So I hope you understood about this is all about the expert system. This code, I'm going to share it with you so you can keep it. Like yesterday, like we will be giving this information through Sudha madam, and this code will be given, and Ranga will be sharing some code in the afternoon. That also will be shared with you. I hope all of you clear about the knowledge and knowledge representation, how the knowledge is codified. Any doubt? We'll proceed further. Okay. And again, you can use this as one way. You can build your own expert system, or you can go with some other packages, right? So what is an agent? Can you tell me some of the agents you have seen in your life? What that agent will do? Question for you. And one other thing.
LIC agent.
Okay. So what is that LIC agent will do? Anyhow, see this here one thing I want to tell you. Alexa. You can Alexa, good. You can download the whole thing as HTML also. Suppose if you want to share the code to somebody, you can just download it as a HTML and share. That way, you can show to your students or other people, and it is because Python may not be read from the, if I open Python from the Explorer and all, it won't work. So rather what you can do is, once again, I'm showing you, this is the code. Like say, now I have this code. Okay. This is, okay, let me
You can delete the
cut all these things. Yeah. So I'll just click this, cut. Okay. Whatever I want to cut, I can select all. I can select all and then cut. I can do that. This is the way you can use a cut. Okay. So I have the code. It's right here. I don't know where I put the code. My goodness. That's my problem. Somewhere Python code, take to, I know where the code went. So now I will use a notepad. There you go. Tuesday agenda. That is a code. There you go. So now I have a full code, right? I simply take this code, Control C, and then put it here, right? Now I'm going to run. So don't walk is the answer. So if I wanted to have this saved, I can download it as HTML or a LaTeX format, right? Just say HTML and it will just download, right? And you can share this, it's going to be easy for you to take the code. So you can also take this from here and then run it. So that's the way you can do. Or else you can download it as a Python, IPYB, interactive Python file, you can say notebook file. So there's another option will be you can file, so save and checkpoint. You can do save as, you can just say expert system. Will save it as a notebook file, right? And then you can just go open, and then you will see in the present place it will put it. Yeah, AA expert IPYB, right? So you can just open it like that, right? So this is how you should use this, Python code. Okay, good. Let's continue on the agent system. Yeah.
Everybody is asking, repeat it once again.
Which one, ma? Whatever.
Sangamesh sir and Vikas sir are asked to repeat it once again.
Now the procedure.
Okay.
The procedure.
Oh, okay, sure. Yeah, basically, if you go there to your Anaconda Navigator, when you are going to your Jupyter notebook, I have a code, right? So let me, yeah, I have a code. Now I wanted this code to be saved, entire results and everything as HTML in a nice format. I just need to do file, download as HTML, right? And then it will just download it. Oh, password for token. Jupyter, what happened? I didn't do anything.
Doctor, do the markdown. Do the markdown.
Yeah, I'll do that. 1 second. Yeah, I will do that. See, one thing is here, every time you can save and checkpoint. That way it will be, saved and then committed. Then you can download as, you can also do a print preview. What do you want to say this?
Why is it asking for a token? You just open it, and paste the word.
I don't know what happened. Anyway, so you can just do the save as and then HTML it will save. That's one option. Or you can just save.
Show them save as. You can also show them, like they can also do it as the Python here. Can they store it as .py?
Yeah. And you can also, you see, once you have this there, here all your Python code will be there. IPYP. See, this is where all my Python code is available. So whatever I have saved, all these Python codes will be available in the default location, right? I hope it is clear. Basically, all I'm saying is you can save.
Yeah, they are getting it as HTML file. They are able to save it.
Yeah. Good, excellent, cool. Let me close these things now, and I will continue my session. Right now, it is 12. I want to finish the agent real quick. Okay, cool. For lunch, I want to finish the agent. That's my agenda. Okay, so agent is anything that can perceive its environment through the sensors and acts upon that environment through effectors, right? So effectors are the one like our hand, arms, right? We use that to make action, right? So basically effectors will make an action and we have a perception which perceives the environment, what is there in the environment, right? Sensors helps to sense, right? So we use that. Agent is anything that can perceive its environment through the sensors. So all we do is perceives, perform action. Perceive, perform action. That is what the agent do. Agent perceives inputs, perform action. How agent perceive inputs? Using the sensor. How agent perform the action? Using the effectors. Are you clear with these two terms? Very, very important. Every time I'm going to use this word effectors, actuators, perceptors. Are you clear about
Yeah,
this
they are saying
diagram?
yes, yes, they are saying yes. Clear.
Excellent. Excellent. There are many types of agents. Human agent, like we are all using the eyes, ears, nose, tongue, and skin, right? So a robotic agent will be using with the cameras and infrared range finders to look at the distance, and for the sensor, there are a lot of motors and actuators for the effectors. So like our hand, how we move, we use that, our body metabolisms to move things. So it has a rotor and motor and other actuators for the effectors. And the software agents, everything is basically coded in terms of bits. Everything is going to be like, say, for example, I want to convert something to something. It's all going to be the encoding. So everything is going to be encoded and decoded in the software. So that's basically the three types of agents which normally we see. Right. Sensor is a device. It's a part of IoT, which detects the change in the environment and sends the information to other electronic devices. An agent which observes its environment through the sensors. Actuators are the components that converts energy into motion. Whatever electrical energy will be converted into mechanical energy. The actuators are only responsible for moving and controlling a system. Okay, let me show the video. See, I took some of my students to Dell factory. This is real. Okay, so where we saw the conveyor belt, there are some robots, and then all the devices are being taken, and then correctly the assembly unit was gone into. There is a little conveyor belt. There is a machine which just takes it and then look at the distance, stop, and then take a left turn and then drop it there. So the robotical controlled the machine will move to different directions in that plant, and then the people will just pick up the items. Still there are human being involved. They just pick up the items and then they start doing the assembly. So this is implemented in Dell factory, where we went and saw, right? All I'm trying to tell you is there is basically that actuators helps you to move and control. Basically left, right, up, down, stop, proceed, take turns. All those things will be given as the then actuators performs accordingly, right? And then effectors are the devices which affect the environment. It can be leg, wheels, arms, fingers. So like placing something or doing all those things, right? An intelligent agent is an autonomous entity which acts upon an environment using sensors and actuators for achieving goals. So basically there are some rules we can use, 4 main rules. An AI agent must have the ability to perceive the environment. That is rule 1. Rule 2 is observation that must be used to make decision. Rule 3 is decision should result in an action. We are taking a rule, like say we saw some rules. No, if it is a rule is yellow light, then slowly walk, carefully walk. If it is a red light, stop. So there should be some action. Rule 4, the action taken by AI must be a rational action. What do you mean by rational action? What do you mean by rational versus irrational? Can somebody give an answer? What is we call the rash drive, not rash, rational versus irrational? What do you mean by rational action? That's why it is called as a rational agent. Like there are simplex agent. For example, I will tell you one thing. Can you all say waiting for lunch? Can you all say waiting for lunch? Can you all say the word waiting for lunch? I'm just doing something, man. Please follow. Waiting for lunch. Very good, Krishnakant. Krishnakant is a good reflex agent. Waiting for lunch. Geeta is not a reflex agent. She's a rational agent. Okay. Waiting for lunch. Good. So you are reflecting. Based on the environment, you reflect. Okay. And, waiting for lunch. Good, good. Enough, enough. I know you are all waiting for lunch. I'm also waiting for lunch. Everybody is waiting for lunch for sure. Okay, cool. So there are different types of agents. We will be seeing some of the agents. But this is 4 important metrics you will be looking at it, or you call it terms. PEAS: performance, environment, actuators, and sensors. Right. So I don't want to go to this. Let me go to self-driving car. Well, performance is measured of the car based on the time it takes and safety performance, legal instructions, how it follows, how comfortable it is when using that self-driving car, and then the environment, what type of environment the car is going, what type of road, what type of other vehicles are all there, what type of road sign, and how many pedestrians and things like that. That is about the environment in which the agent is deployed. For example, the drone is deployed in agricultural land, and what is that it is doing based on that the weather, based on the soil and all those things, it predicts something, right? Actuators are using steering, accelerator, brake, signal, horn. And sensors, like in a car, you have a camera, you have a GPS, you have a speedometer, odometer, accelerometer, sonar. All of them are sensors. So we use these sensors, sensor data, based on the environment, based on the given rules. Actuators will be performing and will keep on measuring the performance and then adjust the performance. That is all about machine learning. Also, what we do, we basically train the data, train the system, and then again improve on the system, right? So let's see some examples of the AI agents. Medical diagnosis system. What is the performance measure? If there is going to be a agent which is doing the medical diagnosis, there will be a healthy patients. The cost is minimized. The environment may be a patient, hospital, staff. Actuators will be some tests and treatment. Sensors will be keyboard. Lot of other entries, right? If you see a vacuum cleaner uses camera, dirt detection sensor, clip sensor, bump sensor, infrared wall sensor, because the vacuum cleaner will be automatically going. It should not go and hit the wall. So it just goes and identify the wall. Infrared wall sensor will be there. And the vacuum cleaner has wheels, brushes, vacuum extractor. And what is the environment? Vacuum cleaner can be worked maybe in the room, maybe in the table, wood floor, carpet, other obstacles will be there. So what is that? What are the measures you measure? Cleanliness, efficiency, and battery life and security, right? So like this, there are another agent is there. I don't want to go there. So have you seen this Turing test in AI? Are you seeing this? Google does this AI Turing test. Turing or Turing is a person, famous scientist Alan Turing. He has introduced a check. Suppose, have you seen that Turing test anywhere? Can you tell me? It just say select the traffic light, right? Add a 45 plus 55, right? Like this, it will add. All those things are all part of the Turing test. Basically, the Turing test will identify whether the opponent is a agent or human. Can basically it just checks. Basically, player A is a computer, player B is a human, and there is going to be interrogator. Okay, the interrogator confirms whether is a player or human. If the interrogator would not be able to identify which is a machine and which is a human, then the computer passes the test. That's how the chess is doing, and the machine is said to be intelligent and can think like a human. So basically, we are trying to simulate all this thing and then checking whether there is a human being or interrogator. Like so, the Microsoft has done some good tests on that. You can check that. Google also. Sundar Pichai has demonstrated nice on the Google Alexa, not Alexa. So Google voice test, and he has shown a demo. You can look at it in the YouTube, right? So there are some of the problems we have when time permits. we'll be showing you some artificial intelligence problem like water jet problem, N queen problem, all these problems, right? So basically, we look at the problem statement, trying to find how it works in the different conditions. So normally what we do is we define, analyze the problem, identify the solution, choose the best solution.
Sorry to interrupt, Doctor. Participants, I've just pasted a link where you can see see that visual Turing test. You can use it after during the break.
Excellent, cool. And implement the solution. So, for example, self-driving car. So you look at the different conditions where I am driving the car. Am I driving on the the suburban street or the city or on the beach side? And what type of road conditions and what are the different ways to address the condition? And then basically the aim is to take the best solution. Mr. Ranga yesterday he told no, there's a greedy method he says, and he says a A* search, right? So basically we are trying to, that's where the AI search algorithm come into picture. Look at the best solution and then implement the solution. There are many types of agents. I don't want to go into more types of agents like simple agent, reflex agent, like that, active agent, proactive agent. But one of the agent which is very important is knowledge-based agent. So basically agent will act upon the knowledge. It will take that knowledge and then reason over the knowledge and also update the knowledge and after the observation and action. So that is called knowledge-based and inference system. So the knowledge-based agent will use knowledge base as a repository and have an inference system. See this? This is the architecture of a knowledge-based agent. There is an environment. It can be a forest, it can be a home, it can be a road, it can be a hospital, right? We perceive the input from the environment. There is going to be inference engine. That inference engine perceives and then gives the output. Okay, inference engine also checks at the knowledge base, right? So what is that? You say you are seeing on doctor, then you say good morning doctor, right? Or there is one is seeing some pulse rate is increasing, some alarm sound. It looks at the knowledge base, alarm sound, what should I do? Message doctor, right? And it also updates the knowledge base. See, this knowledge base agent takes input from the environment by perceiving the environment. Input is taken by the inference engine, and which also communicate with the KB knowledge base, which is nothing but knowledge base is nothing but lot of rules. You can knowledge base can be relational knowledge base can be semantical knowledge base, it can be production rules, it can be anything. Build a set of rules, and the learning elements of the KBA regularly updates KB by learning the new knowledge, right? So this is all about the knowledge. So there is something called forward chaining and backward chaining. Basically, when we do an inference system, it will go either forward approach or backward approach, right? So basically, it will tell, this operation tells there are three operations will be performed by the knowledge base agent. Tell means this tells the knowledge base that what it perceives from the environment. Oh, I am hearing noise. Ask. This operation asks, now what should I do if there is no so much of noise? Perform. Okay, reduce the volume. That is the tell, ask, perform, right? Firstly, it tells the KB what it perceives. Secondly, it asks KB. Thirdly, program tells the KB what action was chosen, right? Because it has taken an action, then it gives that, right? So with that, I think it is now 12:25 and we are almost nearing the lunch time. So next 5 minutes open to a question. So probably we'll have a break at 12:30 or 12:35. Then we'll be back by 1:35. So we can start the session in the afternoon. Now floor is open to the online floor. The Google meeting room is open for any questions. So Ranga given me the link. Yeah, I'll just show the visual Turing test. Thanks, Mr. Ranga. Accept recommended cookie, right? So you can look at this.
Yeah, just go down and it's very nice. Just take the Turing test. It's saying, look at the scene, answer the question. You just answer, where is the cup? Just answer it.
No, not
that. Yeah, it's asking, look at the scene, answer, where is the coffee cup? So on the map, it depends. You have to just on the table, and you just say continue. It gives a nice explanation. It could be anything. Just say
Yeah.
scroll
I
down.
gave.
No, inside. You just scroll down. Here, left side, you see the
Yeah.
continue. Go up. See, it gives a nice explanation. Some people might say it's on the table, while others might choose on the mat. All the possible answers are correct.
Yeah. Cool. Thanks. So continue. That's okay. You can just
play
take this.
around. Yeah, it's very nice.
That is John. John is on the road, walking on the road. Left up the tree near the white car. Oh, so okay, near the white car. Where is the white car, man? I didn't see the white car. Was there a car? This is a white car, huh? Was it a car? My eyes are.
There are some questions, doctor. Sir, decision cases so in some cases decision is biased. Yes, professor, that is right. Yeah, decisions can be biased based
Yeah.
on the rule that has been declared. Then Sharanya madam asks how to make the students project team to work collaboratively in Python. Can you suggest any platform? Madam, the collaborative way is like what we can say is they can come up with functions. They can work on those functions, and those functions can be finally collaborated and combined into a single Python code and can be run, madam. There is no specific collaborate. They can use Google Colab. If you want to use a collaborative platform, they can use Google Colab under a specific Gmail ID. They can keep logging in, and then they can, and also like Professor says, GitHub is a good one.
Open source version control. You can make them to create one GitHub folder and then ask them to share. So that will be very good. And GitHub has some of my students have put a lot of code snippets in the GitHub. And then when you start doing GitHub and many people start using the GitHub, then that person will get good references and things like that, right? So that's the way it goes. I think it is about 12:29. Any questions you have? Any more questions? Then I think we can.
There is one question from Yoga Madam. Can you please share your insights on application of ML in 5G communication?
Madam, the 5G communication is it's a very good question actually, because 5G is going to give a lot of this sensory to us, a lot of vision, all the computer vision models, detection, everything can be done with 5G. So 5G is going to turn the entire speed at which it does, and a lot of other things that 5G can bring will only enhance the machine learning. To name a few, I would, as I said, a good example would be on the control management of IoTs. There's a lot of uses in ERP because the wireless. From what I can see is it has a lot of applications in e-health, because 5G is going to make the vision conceivable. So once e-health is very important, because right now the doctors are struggling to do the analysis of a patient. So right now, if there is an expert in Chennai, you have to travel here to get diagnosed. So the 5G is going to make a big impact, and the e-health is one of the areas that we have been looking at. There may be multiple areas, but it's a very good question.
Yeah, there are actually, irrespective of the areas, we have talked about some of the metrics, like say, even I'm guiding some of the scholars, I'm also giving some advices on, mobile ad hoc network and other thing. So basically, there are a lot of metrics are there. So first, what you need to do is understand the metrics. So what we are trying to do with the machine learning is we are trying to understand the data and trying to build the data and then trying to model the data. And what is the parameter you wanted to look at it? Okay, you want to look at the bandwidth performance on the 5G communication or the split, or you want to look at the accuracy, you want to reduce the error rate, or you wanted to look at any of the attacks in the 5G communication, or do you wanted to look at the resilience? What type of attributes or properties you are going to improve on? Anything you want to improve on, you can just apply into a data mining and crisp technology. You can apply and then start doing the machine learning. So there is no restriction of bare machine learning. Body area network, correct. And man-machine network, MMI, man-machine network, human computer interface, brain-machine interface, BMI, right, everywhere. So there's no,
like doctor said, it's going to just the speed alone, and the capacity of processing and the speed of delivery over the network, will open up a whole bunch of things that you want to do a fraud detection. The moment somebody is walking in, or you can immediately go into the big data, get it checked, and come back. It's a great area for research. I'm sure I have seen quite a few papers already on that 5G and ML. So that is an area where you can encourage your students to write papers on, and it is a great area for research as well. Thanks for bringing that, Indra madam. Very good question. Thought provoking.
So any more question, or can we close? Sudha ma'am and Alirani ma'am, professor, can we take a break and then come back by 1:30?
1:30, sir.
Yeah, good. So thank you all. Hope the morning sessions would have been helpful. So at least now you would have got the expert system. Go with that knowledge and then digest that knowledge, and then think about the problem statement, whatever. I don't know. One quick check I wanted to ask you guys. Did you look at the problem statement? I think you've already shared the problem statement. Have you identified the domain? We have shared about some, I think, 8 problem. Yoga Indra says yes. Oh, good. So just look at that problem and then think about the problem. You might have already seen the problem. There, what we should do. Think about, computer science is a common sense. And, so you have to look at that problem statements and objectives and what type of, expert system we need to build, what type of mining algorithm we need to build, how to represent the data, what data pre-processing you have to do. Start thinking. We want every day you start thinking, and then by end of today, and you also think what statistics we need for analyzing the data. Do I need to apply correlation? Do I need to apply this and that? So think about it. So anyway, we'll have some more sessions and discussion. So thank you so much. Have a
I
lunch.
think we may have to change the lunchtime also, because Professor Ankur Roy has given that his lunchtime is between 1:15 to 2. But majority, I think they accept this 12:30 to 1:30 timings.
Mr. Ankur can eat his lunch and then attend the session, no problem.
Okay, yeah. Parallelly, he can have his lunch with the
Exactly. Yeah, exactly.
Okay. And Yoga Indra ma'am, once again, Yogeshwari has given, please share for space domain, case study for space domain.
Sure. We will send it. I will send it to Sudha ma'am, and then you can take it from there. No problem. Immediately, I will send it to Sudha ma'am, and she will share it. Will do. That's all, ma'am. I think we can stop the recording.
Yes, sir. I'll stop, sir.
Thank you. Have a good lunch, and we'll see you at